Thanks for coming to the QA. So tonight is the midterm. I hope you all know that. It's going to run from 6:30 to 8 p.m. And as before, we have two locations. So if you have your own computer, you want to use your laptop, then come to CIRS 1250. If you don't have a computer, or if you want to use the lab computer, we've made them much faster, so there'll be fewer issues this time around, promise. Come to I6008. Okay, so you have two options. Both rooms are going to be available starting around 6 p.m. So if you want to get there early, get your water, sharpen your pencils, come early. We'll be there. And then just another note, because of all the craziness that's been happening on campus, make sure that you have a safe way of getting home from the exam in the evening. So that's kind of it. So now I'm open to your questions. Yeah?
This test also cover things we have covered before the first midterm.
Does the test cover things we covered before the first midterm? So the test focuses on things that we've covered since the first midterm, right? But that said, if you don't know the material from the first midterm, you're not going to do so well on the exam, right? So you have to know what a type is. You have to know how to read a basic UML diagram. You have to know subclassing, interfaces, all of that. Yeah.
So will we, a better way to ask that question is, will we have to know stuff that was specific to stuff before the midterm?
We assume you have to know everything.
Right.
Okay, so it's cumulative, but we're interested in testing you on the new material. Okay.
So question one of the second midterm is in class B it says that we're trying to where the system out is not.
I can't hear you. Are you talking about a question on a midterm? The sample? Which one?
Question one.
Question one. Okay.
So in class B, the turnout
I can't hear you.
okay, so
You're going to have to shout or people are going to have to be more quiet.
yeah, so in class B,
Okay?
the system out, that print line has just that from method A after the my.a.method A is invoked.
Okay, so let's look at this. So question one. You have it has multiple parts, right? So you have a question about a specific part?
Yeah.
Which one?
Like, I was wondering if the system out that print line would be still performed if the my.a.method A was after the system out.
Can you maybe talk about more specifically? I don't know where you are.
Yeah. So that print line isn't ever.
There's a lot of print lines. Which one?
Oh,
This
the
one?
one that says just back from method A in class B.
You were just on it.
I was just on it. Is it this one?
No, about.
Oh, okay. Just back from method A. Great. Okay.
If method A actually throws an exception, that line is never invoked. But if that was before the my.method A, would that even if method A throws an exception, that would work?
That's right. So the way to think about a try statement is that it's just like any code. You execute it sequentially, one line at a time. And if any of the lines throws an exception, then you stop execution. You do not execute the rest of the try statement, right? And then you go on to handle it. So you have to find a catch block for it, or a finally block, right? So the way, I could draw this as, I have some try statement. I have some statement 0, statement 1, statement 2, statement n, right? It doesn't matter what I have here. So maybe statement 2 throws an exception. So that means I executed everything up to statement 2, including statement 2 or parts of statement 2, and I did not execute anything below statement 2. Other questions?
You go over the question with the task where you got it from here. I think it's question
Question 3, extracting UML from Pacman. Is this checked in? I don't think I have it checked out, actually. Which project is it? Is it just Pacman? So the question is this is question 3 on the sample midterm. Extract UML class diagram for all the types in Pacman model. I've got the wrong laptop. So here I have the Pacman project open. I have a bunch of classes in my model package. Before I made any changes to it, right. So should we just go through the solution and I could explain how we got it?
Yes.
So this is question 3. So this would be I think it's the top one, right? It's not the refactored design. It's the one before the refactored design, right? Okay, so here's the UML diagram, and here's the code. So how do we do this? So we start off in one of the classes. Let's just start at the top. Here's board. And we say, who does board know about? So board seems to be like a pretty central class here. So board knows about a board that is composed of multiple grid locations. So this is a list of lists. That means there are multiple grid locations, right, that the board knows about. So you draw board, you draw grid location. Where's grid location? Am I in the right class? Am I looking at the right answer? I think it must be this one, huh? It must be the refactored design. So have board, it knows about multiple grid locations, so you have a star. So remember, a star is the same. Say again? It is the first one. Oh, yeah. Okay, yeah, there's a line here. I was just confused. So a board knows about a grid location. It knows about multiple grid locations because there's a list of grid locations. So I could add multiple grid locations to that list. And then a star just means 0, ... n. Right? Now, even though this is a list of lists, don't let this confuse you. Right, so really it's a list of lists of grid locations, but what that means is there could just be multiple grid locations. Right? It could also be a map of grid locations. So that also just means you know about multiple grid locations. So we don't differentiate between, whether this is a set or map or list. It would just be star, regardless of this, right? And then it knows about Pacman. So the first one was unidirectional, right? So the way you would know it's unidirectional is because you would go to the grid location and you'd say, does my grid location know about the board? And at the very top, no fields defined to track the board. So you know there's an arrow on this edge. Then you go back to the board. You say, okay, what else does it know? It knows about Pacman. And remember that all of this, you have to evaluate this after the constructor, right? So the numbers on these edges will depend after the constructor. So you have to look at what the constructor does for board. Board calls init board. And init board, well, it does a bunch of things, right? All of these things. A lot of things. So as a very first step, it creates a Pacman. So after my constructor executes, I know about exactly one Pacman. It's initialized, so which is why I have the number 1 here. And then if you look at grid locations, you'll say, do I ever add grid locations or create new grid locations? Nope. So that's why it's still a star. So it's still 0 through n. And you just keep doing that a whole lot. Yeah.
For that question, it asks for the UML diagram for only the model class, but then the game and board panel are not inside the package. So why do the stamps have those two?
Yeah, that's a good question. So I think, so if we had this on exam, game and board panel would not be part of the diagram, right? So they're not part of the package, so you shouldn't really have them on there. Yeah, no.
So say we know about like Batman, right? But in the constructor we don't do anything with it. So would we still
Well, could it be 1?
Sorry?
Could it be 1? So you're asking about the number, right?
Yeah.
So could it still be 1 or not? If I never initialize Pac-Man. Can't be 1, right? It could be 1. What else could it be? Could it be 0, right? So it's either 0 or 1. Right, so it's a single field. So the question is about this field, Pac-Man. And this field, defined at the top, it knows about exactly 1 Pac-Man. So either I initialize it at the end of the constructor or I do not. Which means that later on I could set it, right? So instead of a 1, I would have 0-1, 0, comma 1.
So to figure out how many Pac-Mans you have, do you just look at a constructor?
I have to think through the constructor. That's right.
You don't have to worry about any other methods that might later.
Well, in this case, the constructor actually calls a different method.
Right.
So I have to reason about an int board, and I have to reason about all the things that an int board does. So I have to think about, the way to think about this is maybe just take the control flow graph, starting at the constructor, and you have to reason about that whole part of it. Okay?
If Word has a method called remove Pacman, will it be 0 to 1?
If who removed Pac-Man?
Word has a method called remove Pacman. Will it be 0 to 1?
No, so this is a snapshot, essentially after the constructor finishes. So the way to think about these diagrams is that they say, well, I just created a new Pac-Man, a new grid location, a new board, a new tracker monster. Now draw me kind of the relationships between those without really thinking about what might happen in the rest of the code. So this is very simplistic, right? Just like the control flow graph, just like the flow graph. It's an abstraction of what your code actually does. If you try to put everything in your code into the diagram, it becomes too complex, not as useful. Other questions? Yeah.
It seems to me like grid location would have an aggregation relationship. Can you explain?
Oh yes, the aggregation relationship. So grid location and board could have an aggregation relationship. So this is, it's a tough choice, right? So this is really about design, and this is where it gets murky. So some people would look at this and say, yeah, a board is really made up of grid locations. They're really inherent to the board somehow, right? And then you would say it's aggregation. And then someone else would say, well, a board, has grid locations on top of it. It's not really part of the board, right? So you could go either way. So, say again?
Who gets them right? Like if you did that on a test, which person would be right, which person would be wrong?
There's only one right answer. I think if we did this on the test, it would be unambiguous to you. Okay, so you would know which one to choose. Okay, so there are examples where it's pretty obvious which one is which. And second of all, if you choose one and you feel like you're not sure, you can always describe on the exam. Right? You can say, look, I chose this is going to be a diamond, right? And then you circle and you say, here's why. Right? So it's like this. Just tell me why you thought it was a diamond. And if you can convince me in this little section, sure. Right?
So the relationship between, let's say, game and board, right? So their reasoning would be that game can exist without board. Is that true?
Yeah, so this came up on the Piazza is kind of one way of thinking about aggregation is whether one can exist without the other. Right? So can a game exist without the board? If it can, then it's likely that it's not aggregation. Right? Or it's like, can a grid location exist without a board? If it could, then it's really not an inherent part of the board. Okay, so that, yeah, I think that's a good way of thinking about it. It doesn't always work, right? Because partly this depends on the semantics, right, of the design. So there's a question on Piazza about this again, where you have you might have a car, right? And you would say, are wheels, in aggregation with the car? And typically you'd say yes, right? Every car that I see on the street has wheels, right? And right, to see a car, it must have wheels on it. But then you might say, well, actually, what I'm designing is software for my factory that creates cars. And inside the factory, there's a bunch of cars, millions of them, without wheels. Because wheels are put on in a different factory. And so in that case, wheels are not inherent to the car. So it's very kind of context sensitive. Someone new. More questions? Come on, guys. Yeah. 5B? A. Okay, 5A.
So because of that, we are required to create an instance of event history in the constructor of the user class, right?
Mm-hmm.
But if we do not have that sentence, and we still want to honor the relationship between user and event history as shown in this diagram, then we can create an instance of user in the event history constructor and pass event history as parameter to the user constructor.
You could. There's a couple of different ways of doing this, but I'm assuming that this pinpoint your solution, right? There's really only one way of doing it once you have this information.
Because of that sentence.
That's right. Yeah, so there's a lot of flexibility here. So here you might say that, so I have a class user, and then I have a user constructor. And one way of doing it, like you said, is I can pass payment history into the constructor and then set it in here. But of course, this sentence basically obviates that. It says that, well, you don't need to pass anything in, you can create it. Right? So you can create a new payment history inside of the constructor. Yeah.
It's a general question, but I find an example in the robust account complete about how to write a test for exceptions, and when does this test fail pass?
Right, so general question about how to write tests for exceptions, and when do the tests pass or fail?
And I find an example in the robust account complete.
Robust account complete? That's
And
great, let's look at that.
the robust account test.
So robust account complete, tests, robust account tests. Okay.
And the pool withdraw too much money.
So
The
where do I-
last one.
this one, right?
No.
The next one. Yep. This with try catch. Do we always have to include a try catch in this kind of test?
Well, the reason, so why do we have catch statements at all? Here. Can't they just take these out? You guys should know. Why can't they take these out?
You're trying to test one of the cases in which it fails. So if it fails because of those, then you won't be able to. You only try to test whether it failed. The failure of whether it withdraws.
Right. I was going for something more general though. So like, let's say I comment these out, right? I comment out all the trying and the catches, right? My code doesn't compile. Why not?
Unhandled exceptions.
Right. I have unhandled exceptions, right? These are all checked exceptions. So if I mouse over this, it says you have an unhandled exception, not enough money exception. So this should give you a clue. So when I write a test that may generate an exception, I either have to handle it, right? I have to catch it, or I have to expect it, right? Like I would change my signature at the top to expect that exception, or my test just fails, right? Because that exception escapes, it's not checked, and I don't expect it. So this is, first of all, this is why we have these catch statements at the bottom, right? We must have them. essentially, unless these things will escape, right? Unless we want them to escape. So in this case, you can see that they're all just system out printlns. So there's nothing, you could just comment these out. They're not going to affect the validity of the test. They'll just print something out to the screen. So they're not necessary. So really the reason we have these is because these exceptions must be handled. Okay? Does that explain it?
So for this test, does that catch not enough money exceptions? Will that be catched?
Will that be caught? That's a good question. So, so this test is saying, it has a fail condition here, which means that you're not supposed to get to this line. Which means that very likely you want this to throw some kind of exception. Now, the question of whether it throws this exception or not, I'm not sure. It depends on it looks like a valid value, so it's probably the not enough money exception. That's probably what it's expecting, yeah. Other questions? Lucas?
Could you go over the exception supertypes, since normally when we write along, we just assume it's
Right. So can I go over exception supertypes? Yeah, so exceptions have that hierarchy. I don't have this picture out with me, but typically the way you think about it is that you have runtime exception. So that's a class, defined part of Java, right? And then there's going to be exception. And so runtime exception is the unchecked type of exception, and the exception class is the checked exception. So checked exceptions, you have to declare them when you throw them, and then you have to handle them when they occur, if they occur. And runtime exceptions are just these hidden things, right? It's like, well, things are going to happen, right? Oh boy, like run out of memory. You don't want all of your code to handle that exception, so you declare it as a runtime exception. So when we create new exceptions, we essentially subclass these things, right? So you can create a my exception down below here, or you can create a your exception down below here. And of course, exceptions are just classes, so we can extend them further, right? So I can have more descendants from your exception, right? So I can have A exception and B exception. And so this allows you to reason about errors in your program at different levels of abstraction, right? So you might say that, this, like staying with the car metaphor, you might say this is a car exception. But then a car might have an engine exception. It might have, blinker exception. There's a bunch of stuff that may go wrong with the car. And then there might be just a car exception. So you might say, hey, if I have a car exception, I just want to show you a little yellow light, right? Regardless of what the exception underneath is, right? So that's one way of thinking about exceptions in kind of more abstract way, right? And then your engine might say, oh, it's an engine exception. I better do something. I don't allow you to go over 80 miles an hour, something like that. So these exception hierarchies are very cool because you can have a method. So let's work through an example where I might have, let's say I have a car exception, and then I have an engine exception, right? Which is a subclass. So I might have a class, car, and here I might have some method like public void throttle engine, and this guy throws an engine exception. And there's some code in here. And then besides this class, besides this method, I might have another method further down. Something like public, start car. And I might have a try statement, which does a bunch of things, including throttle engine. Right, so this is a call to this method. And so my catch here can simply be catching the car exception. And essentially what this code will do is that it will, when you start the car, it'll start executing this thing. If there's a throttle engine exception, which is an engine exception, this block, this catch block, will handle it. And I'll handle it because car exception is a superclass of the engine exception. So that's really this is where the type hierarchies and inheritance comes in, exception handling. Okay, more questions?
How do we distinguish unidirectional aggregation, association with aggregation? How to specify whether there is whole to part relationship?
How to know whether there's a whole to part relationship?
Yeah.
So if I have two classes, A and B, right, and I see that inside of B, I have a list of A's. Right? And inside of A, I maybe see, I see a my B. Okay, so this might be my class A. This might be a class B. So there's some kind of relationship between these, right? It's a bidirectional relationship, right? They know about each other. You could have bidirectional aggregation. The part can know about the whole, right? So the reason I made these really abstract for you guys is because it's unclear really what the relationship is between A and B. Right? So it could be aggregation, it could not be aggregation, it could be association, I don't know. It's A and B. So if I rename these to be car and wheel, human hand, then I'll know that it's whole part. If it's basket fruit, then I know that it's not aggregation problem. But yeah, your aggregation will, so this is bidirectional aggregation, right? And then unidirectional aggregation looks like this. And there's only one unidirectional aggregation because obviously the whole always needs to know about the parts. Right, so there's really only two choices for aggregation. Where this holds?
Yeah, because if you have a car and wheel, what would be the section? Only the car knows how many wheels it has.
Yeah, so if this was car, and this was wheel, right, and this would be like 1 to 4, right? Then maybe inside my wheel class, I have a car class, car field, right? And the way you create a new wheel is that you tell it which car it's part of. Because maybe the wheel maybe it measures some sensor, like tire pressure, and then it needs to tell the car, here's the tire pressure, right? So for that, it needs to communicate with the car somehow, so it would have a field.
So a question about hash code and equals. So in course recommender, we generated hash code and equals by choosing the department and number fields. And then in FOB, we did it by choosing the unique ID field. Can you go through the reasoning behind choosing which field when generating the hash code?
Yeah, so the question is about equals and hash code and how would you generate them and what do you include? So here's course recommender, here's the course class. I'm not sure if this is where the that were generated by. But generally, you guys really have to know that you can generate equals and hash code automatically. So this is done through source, generate hash code and equals. So the reason we use this code to automatically generate them is because they can be pretty complex. And there's a lot of redundancy. They kind of look similar. So we can just automate this task. So when I do this, oh, it already contains a hash code equals. Sure, we'll overwrite them. Or we'll remove them. So then this thing will ask me which fields do I want to include into comparison, right? So the answer to this really depends on what do you consider to be important for comparing courses, right? Like if you have two courses and they're in the same department, does that mean that the two courses are the same? If you have two courses and they have the same number and they're in the same department, does that mean the two courses are the same? And it's not easy to figure that out because it will depend on your use case, right? So for example, I might say that, let's say there's a bunch of courses that you're choosing and you can only choose one course per department, right? So if I have a list of courses that you chose, then two courses from the same department are identical if they're in the same department, right? Regardless of the number that they have. So in that use case, you would choose this kind of equals hash code. But then if you're allowed to take multiple courses within the same department, then the equals hash code you would want is this one. So it'll vary. It kind of depends on what you're trying to model. So there's no answer really to this question of which ones do you choose. It'll depend.
Going back to 5.
Okay.
5A. Why in the solutions they make add payment method? Can you just explain why they do that?
So my solution for 5A is down below. Okay, so here I have a class payment history, and I have a method underneath which adds payment. So this guy right here, add payment, is a way for me to grow my collection of payments, so I can add more payments right to my payment history. So this method is not necessary. So if I didn't have this method, I would have the same exact diagram. Okay? Because my payment history can still know about multiple payments. So that's still true because I have a collection of payments. I can have 0 more objects.
So if the answer was like this, would we get would we get the marks?
Yeah, you would get the marks.
So in the constructor, so what I wrote is I also pass a set of payments to the field. So I wrote this dot payments equals hash set payment. Can I do that, or I can only pass the user?
Right. So you can pass any, when you have a question of generating code from a diagram, you have a lot of freedom, except for constraints that are written in the question. Right. So like here, there's an assumption at the bottom that says that the constructor of user class creates the payment history object. So in the user class, I would have a new payment. So I can't pass that in, or it doesn't make sense to pass that in, right? If nothing else contradicts what you just said, then yes, you can definitely pass in, your set of payments here, and then set payments to be this dot payments to be payments. That would be okay.
Would it be different if you omitted the initialization of the hash set after, but you
Oh, you mean if I initialize this guy here? Yeah, that would be equivalent.
We do not write private in companies or like individual parts.
Can you omit the private?
Yeah.
Yeah, you can basically, I mean, it's bad design to make it non-private. I think as far as the question goes, I think you can make it non-private. Doesn't matter.
You didn't wrote anything, does it mean that's public?
No, so there's different visibility. There's private, there's protected, there's default, and there's public. So public means visible to everyone. Default is when you omit your visibility marker. And this means that it's visible to any class within the package. So it's a package visibility. Protected, of course, visible only to my subclasses, my descendants. And then private is visible only to this class. So there's four.
What's the difference between default and
So default means that it's only visible within that package. So I have, here's my packman. I have the model package, right? So if I had a field in any of these classes that was not private, was not protected, was not public, it would be only visible to classes within the model package. Okay? But if it was public, then something in UI could access it. Yeah.
For the last lecture lab we did for alarm systems, could you explain why alarm controller has two aggregate relationships?
Is the solution somewhere in the repo?
Well, the solution's on the video lecture online.
It's on the where?
I was just watching a video lecture on YouTube.
Yeah, but I need to show it to you somehow. Is it on the schedule?
I don't think so.
Is it the, which lab was it?
Alarm systems.
Alarm systems.
Yeah.
Ah, great. What was the project name? Do you remember that?
I think the project name was just called alarm system.
Diagram for a model package. Start by capturing just the class of relationships. And so I have the controller. Yeah. The question is why those are aggregation relationships. For which
There's an aggregate relationship between collections alarm code and collection sensor.
between good and sensor.
Yes.
Yeah, so I think just as before, this is going to be a tricky question, right? So the question is whether an alarm controller can, so let's take Noam's way of thinking about it, right? Can it exist without alarm codes and without a sensor, right? Would you have an alarm controller just by itself? What do you think?
Because I get with aggregation relationships, say if alarm controller only knows sensors, then I get it's probably going to be a aggregation relationship because a part whole thing. But since it knows both alarm code and sensors, so technically can you just say take out sensors and just have alarm code, or you could take out alarm code and just have sensors and alarm controller. So wouldn't that just sort of be an association relationship?
Yeah, I see what you're saying. So if you remove just one, then the alarm controller could still exist without the other one, right? I think part of it could be a simplification, right? Way of thinking about this. So the controller, this is really representing a system, right? It's an alarm system, which is attempting to say that there's all these things and they're aggregated by the controller, right? So it doesn't really make sense to have a system without a sensor, without the alarm codes. It wouldn't be an alarm system. I think that's might be a good way of thinking about why it's aggregation in this case. Yeah.
number 5A. The last statement, assume that the constructor of the user class creates the corresponding payment history.
Right.
Does that mean that we have to pass the user into the constructor?
The constructor of the user class creates the corresponding payment history. So payment history knows about the user, right? So that means in your user class, your user class will look something, your user constructor looks something like, maybe it doesn't have any arguments. Inside of here, it'll have payment history equals new payment history. And now the question is, what does your payment history look like? So if your payment history constructor actually took user as an argument, user u, then in order for me to create a payment history, I have to pass a user. So what would be the user here? It would be this. Okay, so this is invoking this constructor, and it's saying that this is going to be the user u. So essentially that's, this is one way of doing it. Another way of doing it is to say, well, actually my payment history is not going to take a user. And then I'll have an add user guy below. Except that then it's not going to match the UML diagram. Because I really need this to be 1. So payment history knows about exactly 1 user at the end of the constructor. So by the time the constructor runs, that's it. There has to be 1 user. So either the user needs to be created here, or the user is passed in as an argument.
That statement basically saying that the payment history knows about user and user knows about payment history?
That's right. That's what this thing says. And this constrains you. This says that at the end of the constructor of user, it knows about payment history. And at the end of the constructor of payment history, it knows about the user. So there's this, it's a very tight coupling between the two. That's right. Yeah, you could have payment history that looks like so. You'll have payment history, and then inside of the constructor, it'll just say user equals new user, right? And then payment equals new list payments or something. So you could do this. The funny thing about this, though, is that when I'm creating a new user, based on this last sentence, I actually have to create a new payment history, right? So when I create this user, you sort of want to pass this into the user. You want them to know about each other. Otherwise, the user is going to know about a different payment history that it creates. Right? So it becomes a little weird. So this solution is definitely stranger than the one on the top.
Would it be reasonable to just write that?
Would it be reasonable to just write that? I think so, yeah. I mean, there's nothing here that tells you that the payment history I create here knows about this user that created it, right? There's no constraint. So, sure.
For 5B, I think there was one point in your lectures where you had a list of big O between list, linked list, and hash sets.
That's right.
How do we use that to answer that question?
Choose a suitable data structure for a Java collection. So here's my Java collections, right? All these things except for tree set, right?
Is there a place where we can find this?
Yeah, they're online. They're on the schedule somewhere. Should be under collection classes. So keeping that in mind, you want to create a data structure for each of the following problems. So first one, you're writing a system to manage a hockey pool. For each participant in the pool, you must be able to track a team of players. What data structure will you use to represent a team of players? Great question. So, any guesses? I guess you guys saw the solution. Okay, so I have a hockey pool. So, hockey pool is going to be my class, right? And then I have some, player, maybe. Is going to be a participant in the pool. And you must be able to track teams of players in my hockey pool. So a team of players, why not a list? Could I use a list for this? Why not a list? Why is a list a bad idea? I don't want it to be ordered. Well, maybe order is good, actually, right? Maybe I can order them by height, by abilities, something like that. The main issue with a list is that a list allows you to have multiple items that are the same item in the list, right? So you don't want the player to appear multiple times in that roster, right? So that's why a list is not great. You could use a set. A set is a great data structure for this. You could also use a map. There's really only two options. You could have set, player, players, or you could have a map. And the map might map strings to players. So maybe maps names to player instances. So I think either of these solutions is fine for that one. Your question there?
Do we have access to that JCF on the exam?
JCF, you mean this thing?
Yeah, that chart.
No, you do not have access to this thing. You have access to the Java API, which...
Does it have information about that?
So it knows about each of these, right? So each of these is a page in the Java API.
And it lists the big
It does not... I think it does, yeah. Yeah, I think it does. You should take a look. If not, memorize them, Pretty easy. All right, should I do B in this one? Okay, so let me do, or 2. So 2, you're writing a system to manage photographs. And each photograph may have keywords assigned to it. You may want to be able to efficiently retrieve the photographs associated with each keyword. So whenever you see this keyword associated with each keyword, you should immediately think about a map. Okay? It's an association. I want to associate something with something else. Right? So I have a keyword, and I want it to map to photographs. So it's photographs, multiple. So very likely this is going to be a list of maybe a photo, right? So this is my key, this is my value. My key here is a keyword, maybe it's going to be a string. And the whole thing is going to be a map. Okay, so this would be an answer to 2. Yeah?
You go to question 2 in the supplementary.
Question what? 2. Question 2. Extracting AML diagram.
Yeah, for the photo class, it says, on the solution, it says that it has 1 album, but the photo constructor doesn't set an album straight away, so could it have considered 1?
So the solution says that it has exactly 1 album. So this guy, right? A photo. Knows about exactly 1 album. We're going to have to take a look at it. Photo album base. Let's see if it's checked out. Oh, it is. Okay. Yeah, so here's the... Oh. So I have a constructor. I set the name in the constructor. And I did not set the album. Yeah, so this seems like a 0, 0, 1 thing. Yeah. Okay, see you all tonight. Good luck on the exam.
You guys gonna study or do No, because the thing is, at first, like, when it was actually, like, I stopped doing it every day when I was but, like, you know, when you stop, it's like, you can't, for me, I guess you're training. It's training to be prepared. Trainings are crazy. Family trips, I'm just like, oh, this sucks.
They, like, talk about the go, and they can, like add and remove stuff. We have, but I mean, hash oh yeah. It's still weird. It's nothing. But it has the same like to add. Your choice.
What is